Hello and welcome to the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. I'm your host, Jared Green, and I've practiced as a geotechnical engineer for over 18 years. And in addition to practicing engineering, I enjoy mentoring young engineers and first-generation college students. I've focused on helping to increase the number of pre-college students that are interested in STEAM majors and fields. By STEAM, that's science, technology, engineering, art, and mathematics. In this episode of the Geotechnical Engineering Podcast, I will be interviewing the co-host of the Structural Engineering Channel podcast, Mathew Picardal, PE, on what he has done as a structural engineer and what he thinks the geotechnical engineers need to know. We're gonna have a great conversation here. Matt is a structural project manager at BCI Engineers and a structural engineering YouTube content creator with over 40,000 subscribers and 1.5 million plus views. His project portfolio includes the design of podium, commercial, office, retail, mixed use, hospitality, residential, religious, and K-12 projects. His knowledge of wood, concrete, steel, and preferred construction techniques allow him to help clients meet their objectives by providing solutions that are efficient, practical, and profitable. Through Mathew's YouTube channel, he helps young structural engineering students and professionals learn about the technical and business skills required to design projects and the soft skills necessary to communicate their solutions and manage people and projects. And with that, let's jump right into our conversation with Mathew Picardal. All right, welcome to another episode of the Geotechnical Engineering Podcast. Matt, welcome to the show. Welcome to the show. How are you doing?
Thanks for having me. I'm doing great, Jared. How about you?
I'm doing well. It's good to go from watching your show to having you on the show. I'm starstruck. This is awesome having you here, man.
Yeah, no, like honor to be here. I mean, it's I know we're kind of like on the sister brother podcast, so it's great to share each other's network.
Yeah, no, this is great. This is great. And for our listeners that may not know you, Matt, can you tell us a little bit more about yourself and what you've been, what have you been up to in your career these days?
Yeah, sure. So for me, I'm a licensed civil engineer in California. I practice in structural engineering, obviously. And yeah, that's my full-time job. But on the side, I like to get involved with ASCE, YMF. I'm one of the officers there for this year, and yeah, I've been doing a lot of stuff this year. Keeping up with my YouTube channel. It's a structural engineering career channel where I target it towards students that are interested in structural engineering to show them what it's like. And obviously, I do the Structural Engineering Channel podcast. And lately, it's been studying for my SE exams. So that's what I'm focusing on recently because it's getting towards April. So definitely locking down and focusing on that to pass the last of those exams.
Wow. So a lot to unpack there. So YMF, that's younger member forum, right?
Yep.
Okay. And is that under 35? What's the cutoff? Because I remember when I got
Yeah.
to days, I felt a little left out there. What's the cutoff for YMF?
It's
35?
35. Once you hit
Okay.
36, you're out. I know for me, yeah, I still got a couple more years left, but I'm getting there. Definitely in my 30s. So.
Okay. Cherish it while you can. And then you said the SE exam. So how does that compare to the PE? Just because again, we got geotechnical listeners here. We're learning about you right now.
Yeah, sure. So the PE, I know everyone has to get that in the US. So compared to the PE, this is obviously all structural. It's a two-part exam, so it's 16 hours total. There's a gravity and lateral or earthquakes.
Okay.
And so it's spread out 2 days, similar to the PE exam. If you're in California, you take the PE exam one time, and then you can take the surveying and seismic exams in California separately. Same thing here. You can pass the gravity and lateral. But yeah, it is. I mean, it's pretty brutal. It's 16 hours total. Last time I took both at the same time, which was I probably shouldn't do that. It's a lot if you try to study at once. but at least I got the studying done and I passed the gravity. So,
Okay.
which is great. Now it's just passing that lateral portion. So I can just laser focus on that. But yeah, it's compared to studying, I would like a good estimate if you're trying to study for both exams, it's probably around 300 hours of studying to for
Wow.
the SE compared to the PE.
Oh my goodness. Oh my goodness. And it's I guess it's all computer based at this point now, right?
It's actually still paper based.
Really?
One part of it that's tough, and the pass rates are low, like sometimes even as low as 30%. And kind of the reasoning for that is it's still paper, 40 questions in the morning, but in the afternoon, it's
Mhm.
all handwritten. It's like an essay. So you're
Wow.
graded by your peers. So your logic has to be correct. You really have to show you know what you're doing. You can't like guess.
Okay.
And I think that's one of the reasons it makes it so hard because you're graded by your peers.
Got it. Got it. Wow. So I think of the PE, I think it backs out to about 6 minutes per question, right? But I guess if you're doing essays, there's gonna be some that's gonna take some, longer than that, right?
Yeah, for the building portion, they have it for bridges too, but I took the building portion. It's
Mhm.
4 questions in the afternoon,
Mhm.
1 hour each basically. You have 1 hour to do each in-depth essay problem with all your
Like being
calcs and everything.
like being in school again. I don't miss
Oh
this.
yeah.
All right,
Good
great.
experience though for sure. I mean, I think my opinion is it's good because
Yeah.
it really reinforces all of the gaps that you have in your knowledge.
Excellent. Excellent. So I would call you out for the two puns there, reinforcing and gaps, but the engineer in us. Awesome. So Matt, tell us again, our listeners are geotechnical engineers. Some are in school, some are just starting out and they're interacting with structural engineers. But how would you explain what a structural engineer does? And then the types of work that a structural engineer gets involved with, types of projects? What are things that come to mind for you?
Sure. So the way I like to explain structural engineering to people that aren't too familiar with it is it's basically like a human body. The
Hmm,
architect is going to have that vision, how big that body is, what color their hair is, how big your muscles are, the overall vision and the function of it. And then the structural engineer will come in there and we'll design the skeletal system and the muscles to basically make sure it stands up straight and it doesn't fall down under its own weight or any earthquake, wind forces, any of that. Of course, there's mechanical, electrical, plumbing. Those are like, the cardiovascular systems, nervous system. That's like the building, right? And then when in geotech, I like to compare it as the foundation for the human body, it's the feet. That's like the footings, the mat foundations, pile foundations.
yeah.
But where the geotech really comes in and where we work together a lot is figuring out how to best support that structure, that superstructure, because we're relying on the geotechs to tell us, hey, what type of soil is it? So if you're comparing it to, and it's so important because it does make a big difference. I mean, if you're walking, there's a big difference whether you're walking on grass or concrete, or maybe you're walking on the beach,
Yeah.
or even the snow. It You need different types of uh, foundation systems for those. So I think working with the geotech, we can figure out the best way to support that that building, and it overlaps a lot. I mean, I've overheard you mention like it is structures. I mean, for the most part, it's
Yeah.
we deal with more steel, concrete, more the defined structures. But geotech, there's a lot of unknowns, and you only have a limited sample size. But essentially, you're still breaking down the soil structure to its components and trying to find some allowable bearing pressures or geotechnical values that you're basing it off of the strength of materials.
You're absolutely right. You're absolutely right. How do you think what's the best way to choose between structures and geotech? Let's say you're finishing school and deciding which way to go for a master's or where to work. How do you choose between the two?
As if you're a student, and depending on your school too, because some schools are more practical or less practical than others, I think the best way is to just, especially now, if you're really deciding between geotech and structures, go talk to a professional. A typical, and it's easy on LinkedIn. You can kind of just ask for informational interviews. Just like, hey, I'm a student. I'm deciding between geotech and structural. Do you have 15 minutes to kind of just show me what your work is like. And a lot of professionals are willing to to offer you that time because they were
Yeah.
students too, especially if they were like your alumni. It's so easy
Yeah.
on LinkedIn. Go on LinkedIn, find out your alumni that are working in those places that you want to work, and it's an easy reach out. If not, you could always go to those professional organizations. I mean, those are all volunteer organizations and they want to help students out. Like ASCE, they want to help students out. It's an easy ask. You don't have to worry about being rejected or anything. And yeah, besides figuring out straight from the source what the work is like, uh, what you enjoy in school too. So, and what projects you enjoy. For me, I was actually in that boat where I really like geotech, I really like structures. But then when I had group projects and I really just found structures to be just a little bit more interesting because uh, it was, I think for me, I mean, one of my professors, I think it actually came down to one of my professors kind of like showing me the light of how simple and complex structures can be. And when he broke it down for me, I kind of like saw the matrix of structure. It was like, oh, it's so complicated, but if you break everything down into a free body diagram, it's doable, it's understandable. Because it was really intimidating for finite element analysis and stuff. I was like, whoa, that's crazy. But then you simplify everything down, everything is goes back to statics. And to me, I was like, oh, now I can understand. It's kind of like understanding the coding of
Yeah.
a program. You can understand it now if you know how to simplify things. So for me, that was like what drove me to structures. And it's going to be different for everybody else. So I mean, some people might really find that in geotech, and the type of the passion that you have for the subject. I mean, if you want to learn more about that subject, you want to learn all that you can. I think that's a good indication that you really like that profession. You really like that type of engineering.
No, that's awesome. You're absolutely right. It's amazing. When you think about the undergraduate degree for civil engineering, you just touch on each one of these. You don't really spend a lot of time. So, if one of those fundamental classes stuff starts to stick and you start to delve into it, it's like maybe this is the one you want to flesh out and study. And I think you're right that if you could tie it back to the basics, and if you can make it make sense, then it becomes more exciting. Because I know a lot of times people get intimidated by engineering in general, right?
Exactly. Yeah, it was. Yeah, uh, simplify it. You can understand it. It becomes a lot more fun because you can. I mean, you're in control of it. You understand it. You understand the fundamentals.
Yeah. I like your analogy of the body. Sometimes you get on projects where, perhaps you have somebody that's developing for the first time and they think, I just need to have an architect. We're just going to need an architect, right? But, sometimes people don't realize this is tragic, but sometimes people don't realize they need a structural engineer until, a city official or a professional requests it. So, you know, what would you say when you want to tie in why you need a structural engineer? And again, the body analogy is a really good one. But what would you say to somebody that's developing for the first time and thinks all they need is an architect?
Yeah, I
No
think.
offense to our architects, right? We need our architect.
Yeah, absolutely not. I mean, what I would say to that is, I think first, as structural engineers, and I think as engineers in general, we can do a better job of showing how we would add value to the project, to a developer. Because I think a developer only thinks they need an architect, but that's kind of ingrained in their mind already. Uh, but once you get an engineer on board, then we can start to show, hey, here's why we're valuable. Here's why you need us. Just besides the permit, maybe depending on what the developer and architect are looking for, structural engineers can add a lot of value. They can give you different options for what you're trying to achieve in your vision. Maybe it's a more sustainable solution if that's the thing that you're looking for. Maybe a cheaper option if you're looking for the lowest cost. Hey, what's the cheapest thing that we can do to uh, achieve your vision, your goals for this building? And it's different for each and every owner, kind of the path too, like because there's a lot of different solutions. There's modular, there's wood, there's steel, there's concrete, there's different construction techniques. And having a structural engineer on board can at least give you a better estimate of what the costs are, even though we're not doing all the cost work, but at least a preliminary sum uh, a schematic design cost or the preliminary cost of the building and what it's going to look like, what the skeleton's going to look like. Because yeah, you really do need the skeleton first. And I think as structural engineers, we should do a better job of communicating our values. Same thing with geotechs. I mean, their input on the geotechnical reports so important. I mean, I know for me, I read the majority of the geotech report because there's always those little things that's like, oh, that's going to affect our structure because of this. Maybe it's the sulfate or something, you know?
Yeah.
So working as a team and really trying to add value to what the owner's vision is, what the architect's vision is, I think that's where we can add value as a structural engineer, a geotechnical engineer, and as a team.
Yeah, you're absolutely right. It's amazing. We work so closely together. That's why we want to make sure, we had listeners are saying it'd be great to have a structural engineer come on and talk, right? Because the reality is that we do a lot together. And oftentimes, when I get brought onto a project and they're saying, we need you to drill borings at these locations, a lot of times the first question I'm asking is, do we have loads from the structural engineer? Like I need to know not just what the rendering looks like, but how much is this going to weigh and what kind of structural systems are being considered. So knowing that early is very helpful, really helpful.
Yeah, like you were saying, it's a shear wall system versus a moment frame system. Different structural systems produce different loads, which affects the foundations, which affects the geotech report. So that's why it's so important to have those things on board because, for the cost of a structure, the foundations are oftentimes one of the most expensive things. So
Yeah.
definitely one of the important things to have structural and geotech on board for a project.
Yep. And then the earlier the better, definitely.
Yep. Pile foundations versus spread footings is
Yeah.
that's a big cost.
You don't want to find out about that during construction documents, right? Oh,
exactly.
So Matt, when you think about, there's many differences in the way you approach a problem and the way I approach a problem. And, especially when it comes to like modeling structural and geotechnical behavior, what would you say as far as, what would you say that, when you start to identify the differences in our approaches from a structural and a geotechnical standpoint, how can we move towards a more integrated approach to designing projects? What are your thoughts there?
Yeah, in terms of modeling, I know we have different procedures, but in terms of trying to integrate those together more holistically, I think at some point there needs to be um, maybe not for all the projects, but for projects that are uh, maybe costing a little more or they're a little more unusual. If it's spread footings, it's pretty typical default values. But maybe if you're heading towards a mat foundation
Yeah.
or pile foundations, I think getting that communication in where maybe there might be some soil structure interaction,
Mhm.
possibly, where I think there's a little more communication between the geotech and the structural engineer, where I think that's where we can add value. Like, hey, if we have piles, what can we do? Here's what we're trying to achieve. We're
Mhm.
working with the construction team. They would prefer these types of piles. Is there a way we can do that? Or finding solutions on, hey, what if we, you know, working with the contractor, we can find out which piles they have that are readily available that they prefer to use,
Yeah.
maybe the size, and then working together with the geotech. Hey, what are those loads or those pile bearing values, mat slab values, and I think when it gets to that point, that's where we can um, start communicating better in terms of even modeling because we model a structure a certain way.
Mhm.
We obviously use your soil bearing values, so for modeling our foundation, we in our computer programs or we use your. I mean, a lot of it is dependent on your bearing values or your soil values. And I kind of don't know the way the geotechs model it. I know for us, like you give us the bearing values. Sometimes we'll put like a spring foundation on a mat slab and model it that way, but it is dependent on the geotechnical report. So I'm kind of curious about that. Like, kind of what's the modeling procedure used for most typical projects for geotech?
That's a good question. I mean, a lot of times, if it's a simpler project, you're getting, a bearing value. But once the project becomes more we want to say more elaborate, or if it depends on, if we have more structural information, we can do more like area springs. So we know what's going to happen at this wall, we know what's going to happen at this portion of the slab. But once we start, especially if you're talking about like a mat foundation or a pile supported mat, at that point now we're talking like I have to model, you have to model, and we have to see what each model is saying, and we have to keep basically running this iterative approach until we have convergence.
Yeah.
Because you'll look at your model and you say, well, I'm getting more settlement in this area, and I'm saying that it's not really going to settle that way based on what we know from the soil, and we know from the structure it should settle like this. And so we keep, you model, I model, you model, I model, until we get to the point where our models are saying the same thing. And yeah, I mean, we've seen sometimes that could take 2 or 3 massive iterations, as far as a run your way, then back to me, your way, back to me. And I think that you can't do that on every project.
Yeah.
You need to make sure that your client knows that that's going to happen, and how much time that's going to take, and how much, ultimately how much that's going to cost. But for the larger projects, you find that by doing that, you do have a foundation that's specific to that site. It's not just a rectangle with squares underneath, right? It's like you may have a more, higher concentration of piles in an area where you have a higher concentration of load and settlement. So you wouldn't do it for every project, but for some of the bigger projects, you find that at the proposal stage, that you're saying this is something that we want to do, and make sure the structural engineer and the geotechnical engineer are on the same page for what the approach is.
Yeah, and like you said, most projects, simple projects, I mean, we do stuff by hand too, but definitely like you're saying, when it gets complex like that, there is that finite element models going on. And yeah, definitely that back and forth and that communication's definitely key.
Yep. And then when you think about communication, and again, we're in school, we learn communication, but do we really learn communication? What do you think about the communication between the geotech and the geotech and the structural engineer? Where do you think there's room to improve? And how would you say it's best to improve, especially for a young engineer just starting out?
For the young, yeah, for the young engineers, I know for me, I've gotten used to just when I'm looking at a problem and I have a question about it and I'm thinking like more than 5 minutes, is this what they meant?
Yeah.
How do they come up with this value? Because if I go with this, then I might have to redo some work if they're wrong. If I'm going in that type of loop, I just pick up the phone and call or
Yes.
send an
Yes.
email because
Pick up the phone and call. Yes.
it's it's like it's simple, but I know it's difficult for the younger generation. Uh, but I mean, it really is that simple. There might be a miscommunication that you can solve in less than a minute. Like, hey, we saw this on XYZ. Is that what you guys meant, or is this what you guys were thinking? Uh, maybe not, but you can find the answer almost immediately if you just call.
Yeah, it seems like a far-fetched notion, but by all means, pick up the phone and call. It's so much better. Sometimes we get in this thing of, sending emails and emails. But like if you pick up the phone and call, a lot of times, especially if you can get the author of the report,
Yeah, I
you can
think
find out what we're thinking, right?
exactly. I mean, that's the same thing with the structural thing too. Sometimes our loads are overestimated, like maybe way overestimated because it's so preliminary. But then if you call, it's like, oh yeah, well, let me dig into that
Mhm.
specific area a little more. We can reduce it. So yeah, picking up the phone, communicating, uh, especially if you think they're making assumptions. And I don't know, maybe it's like I was thinking about it too, how we can better as an industry. I don't know if people have classes on how to reach out and how to
Mm,
communicate. I know for me, when I went to school, there was a tech communication class which really helped. It taught
mhm.
us all about professional email writing,
Wow.
like kind of how to sound professional, how to get straight to the point. Don't do a
Yeah.
narrative. Just, hey, everyone's busy,
Yeah.
get to your point, respect people's time, never write an email after you're angry. Like, type it out, but don't press send. Like,
Yeah,
cool.
right. Write it and then delete it. So wait, that was
Yeah,
a full semester class on
it
like,
was.
oh, that's cool.
It was technical communications,
Mhm.
and it was really great because it taught us how to it taught us how to be professional communicators in an office environment.
Wow.
Also, public speaking, like and you'll do it all the time. Once you get into a office environment, you'll present in front of your colleagues for this and that. So it was even public speaking.
Oh.
Maybe they could have added a phone segment where like, hey, how
Yeah.
to politely reach out, how to politely talk to people. Because sometimes it should be embedded, but not everyone gets that training,
Yeah.
or not everyone gets exposed to that on a daily basis. So sometimes it's awkward for some people, and maybe just simple training could help.
That's a good idea. And then the courses you're talking about, was that like housed within the communications department or within the engineering school?
It was within the engineering school.
Oh, that's awesome.
Yeah, I went to Cal Poly Pomona, and their philosophy was really a practical one.
Mhm.
So it was mandatory for all engineers pretty much to go through that. And yeah, one of the best classes, most practical classes that I took, especially if you're going into an office environment.
Yeah, that makes sense. I mean, the reality is that, and I asked that question that way because, there's a communications major, right? So it's like the scholarship exists out there as far as whether or not we're tapping into it is the question. And I think that another thing that comes into play is that, if you're a young engineer starting out, all the people you're going to call are going to be new to you, and you might not realize that the two firms probably have a lot of synergy. So it's not really a cold call. For you, it's a cold call, but you're calling, it's a warm call. The company knows you, they've done work with you before. So don't be scared.
Yeah, exactly. I mean, once you kind of get over that, you learn that people are people, and you learn that there's different personalities, and you kind of learn how to adapt to different personalities. But it's a skill. I mean, it's not like if you're an introvert you can't do it. Anybody can do it. It's just you haven't been exposed to it, you haven't been trained enough, you haven't been had enough exposure to it. But it's all skills, and they're very important for any engineer.
Yeah, absolutely right. Absolutely right. And what would you say if I said the one secret tip that you think geotechnical engineers may not know about structural engineering? What would you say that is?
I'd say maybe not a tip, but an observation is that
Mhm.
we really appreciate good geotech reports. Like when I go through the geotech reports,
Yeah.
I know I really like some that are like, oh, this tells me exactly what I need. This goes through all the conditions. It's easy to read, and it gives us the values, and they're really clear, and they even show us all their test data, or if they're doing borings, they get really in depth. They give us a lot of good information. And then
Yeah.
some are kind of just vague. I'm like, okay, now we're gonna really need to have a conversation. But I think we're I don't know, I think we're the ones that read the geotech the most, the geotech reports the most.
Awesome.
And we do appreciate those. Maybe another, I guess, secret, or maybe not a secret, but I think in geotech more, but even in structures, there's still that there was like this one quote where we're dealing with materials that we don't completely know the exact properties or how they're going to behave.
Hmm.
uh, I know with geotech, like people think we know the exact, when we're doing a finite element analysis, yeah, that's the exact strength limit that it's going to have. Well, no, there's so many guesses, right? They make the mix a certain way. uh, when we're doing steel properties, they pretty much always manufacture it a little stronger than it is. So even when we're modeling stuff in our models, it's not 100% accurate,
Hmm.
and I don't think it ever is. But there is still that factor of safety and expected properties or unexpected properties that we have to take into account, and a lot of it is incorporated into the design.
Mhm.
But I think that's even something that a lot of people don't know. I think they
Yeah.
think structural engineering is super precise. Well, to a point, but there's like, unless you're doing a really complicated analysis like performance-based design, and where you're going into the nonlinear elastic limits and all that stuff.
Yeah.
I mean, 90% of our design is still the design that's being used like 50, 60 years ago,
Mm.
where it was like derived by hand calcs.
Yeah.
And we kind of just go, okay, here's the earthquake force. Let's multiply that by 2.5,
Yeah.
because that's what we just came up with a number or tested a number. So a lot of it's still, I think that's what amazes me. It's still vague. Like it's
Mm.
not even a precise science yet where you can uh, get that exact number. A lot of it's based off of testing and Who knows what goes on in the testing where they come up with these amplification factors.
Mm,
So it's yeah, it's kind of like, yeah, let's just amplify it by X amount because I don't know, we tested it like that.
but
So
it's worked.
it's
It's worked before, right?
yeah, exactly. And so yeah, I mean that's always interesting to me, and knowing that, yeah, but it's good enough, I think, at least where we can feel safe and
Yeah.
uh, protect the public. So, but
So
when
it
stuff
works.
goes wrong, we can take advantage of it. Like, oh, we know the concrete's stronger than what we specified,
Mm,
or stuff like that, or the redundancies in the structure. So,
got it.
I always thought that
Yeah.
was interesting.
And as geotechs, we're looking at, we're looking at soil, right? Which is a particulate matter. So we're like, yeah, the structural engineer is definitely a little more specific than what we're doing here, right? But when engineering and you're engineering material, understanding those limits is key for what each one of these structures. So really good point. Really good point. When you think about the future of structural engineering, I mean, what do you
Yeah.
think? What can we expect from the future of structural engineering?
So, what I've been seeing in the industry is a lot of dependence on software,
Hmm,
which I think is good, but not really. I think a lot of younger students are focusing on, hey, what software should I use? What software should I use? It doesn't, like, the truth is, it doesn't really matter what software you use, because I know we've never not hired an engineer because they didn't know a software.
yeah,
If you learn one software, you can learn them all, because if you know the fundamentals of engineering, you can learn any software. It's just reading the manual.
yeah,
It's not really a huge skill. It's something that we can teach you. But I see the industry getting more and more like that. A lot more automation, a lot more computer-based designs, and I think there needs the structural engineer, probably even the geotech engineer, has to evolve with that. Like, because the route you don't want to take is, the garbage in, garbage out, where, and sometimes you'll see it too. You'll ask an engineer, a younger engineer that does a model, is it, how do you know that's right? Well, the computer software told me. And it's like, okay, I'm not going to put my stamp on that.
yeah. It's like that's
I'm
not the
not
answer
putting
I
my
wanted to hear.
liability on that.
Yeah,
And I think engineers, structural engineers, I think they need to evolve more into instead of all the calculations and all the procedures like ACI, this XYZ procedure, I think it has to go back more to the fundamentals, because you have this fancy finite element software. How do you know it's telling you is right? Well, you look at the behavior of structures. When you're looking at a simply supported truss, you're expecting tension at the top, or tension at the bottom, compression at the top. Is your model showing you that? How is your model deflecting? Is it behaving the way you're expecting it to behave? And things like that. Knowing how to check, or at least some sanity checks for your computer analysis models, is, I think it's going to be crucial, because if you don't have that, then I mean, you're not really doing what an engineer is supposed to do. They do this stuff back in the day by hand,
yeah,
and if you can't anticipate what the software should be giving you, then that's dangerous. And I think uh, newer engineers should really focus on that. Always check, like, how do you know that's right? Give me a check. Give me some sanity check, whether it's maybe an example problem. You double check the software with a textbook example problem. It's giving you the same values. Great. I
nice.
think we think you're modeling it correctly then. And doing all those checks on what you should already have the design in your head before the software spits it out. The software is going to give you all those small little details that are more tedious.
Mhm.
Um, but once you get really familiar with it, that's when it becomes to your advantage, because you pretty much know what the software is doing, and you know the ins and outs of the software, where it tends to mess up, where it tends to overestimate or underestimate things.
Mhm.
So yeah, I think the newer engineers, the profession needs to evolve with that, instead of like moment distribution. It's like
Yeah,
a really old method of like calcs that no one uses anymore.
yeah,
Uh, but you should know, like concrete column, you should know there's, where's the tension at? Where's the tension at? That's where we're going to put the steel.
yeah.
So fundamentals like that, I think, needs to be more emphasized than the older by hand methods, because realistically, we don't use those anymore. We use computer programs.
Yeah.
And yeah, that's my opinion. I think maybe the old timers might have a different opinion that you should learn all those hand calcs, but I've never, I don't know. That's just my opinion.
I appreciate it. I appreciate it. No, there's understanding again, back to the fundamentals, understanding why we do things the way we do, even if it's a little more tedious, understanding why we do it. It's like, all right, now I know how to do that. Now we're gonna do this. But I think that you're right. It's like if you're using these, computer software, if you're using them as a crutch instead of a tool, that's when we have a problem, or we could have a problem. So really good point. Really good point. All right, cool. Well, I think we're into pause right now. We're going to come back in a minute with Matt to close out with our career factor safety in segment. Stick around. All right, welcome back. It's time for our career factor of safety in segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Matt Picardal. Matt, you've already had a very successful career, and your career's still going, of course. But when you look back at your career, what's one thing you implement into your career to give yourself a factor of safety?
I think one of the most beneficial things I did and spent time on was, I'd say, the communication skills and the organizational skills, or whatever you want to call it, soft skills. I think as engineers, we're always going to be technical. Like that's who we are. We're technical people. That's where we went to school for, uh, you know, probably high school, college, sometimes even a master's degree. We're technical. That's what we're typically trained in. And that's great. That's what we're supposed to be good at, and we are good at it. But then when you get into the industry, everyone's technical. Like if you want to stand out, unless you're like a super PhD student or whatnot, you're pretty much going to be on the same level as everyone that you're talking to in your field. So that's not a great way to stand out because great, you're another technical person. We can just hire another one of you. You went to the same degree, same grades. Like, what's the difference? Like, one way that I think I differentiated myself, was learning those communication skills, uh, organizational skills, because those are the ones that are usually lower on an engineer's skill list. They invest no time into it. They probably haven't taken for example, a public speaking class. Uh, a lot of them haven't taken that, and it's something that you're probably going to be end up doing in your career. And it's so important for to learning how to present yourself in front of decision makers and even your colleagues, because you're going to have to go to an interview some way somehow. You're going to have to go speak to a person. They're going to have to make that decision. And I can tell you from experience, for example, when we interview candidates, we rate them on technical ability, but we're looking for leaders that are going to be beneficial, that are going to be there for the long term. And that is like kind of the X factor that we look for. Hey, can they communicate? Can we see them in a leadership position maybe 10, 15 years? And you can communicate a lot of that if you work on like speaking skills, for example. So it is a skill. I want to emphasize that. Take a public speaking class. With me, I was horrible at first, and for sure, it's definitely a skill, just like driving a car. I know we're not natural at it, but you can have some type of minimum bare proficiency. It's like you're already capped out at your technical.
Yeah.
Your skills are here, even though you might not be the greatest. If you just do a little bit, I mean, it's going to make you that much more whole of a person and as an engineer. And long term, companies will appreciate that. They can appreciate that uh, you're organized. Even like reading books on organization, productivity, you're going to take that with you forever. Like all those little tips, all those little skills that aren't technical, that's going to help you in the long run, and they're going to stick with you forever. Technical communication skills, uh, forever. I mean, you're always going to be writing emails, you're always going to be talking to people, always communicating. And yeah, it amazes me that we don't try to emphasize that more in general.
Absolutely. Well, that's a good one. Thank you so much. Well, Matt, thank you for coming on and thank you for sharing all the great insights that you did. I'm sure that our listeners are going to agree with me that there was a lot of great information and advice that was shared here. Now, if listeners wanted to reach out to you to learn more or to connect with you, what's the best way for them to find you?
The best way to find me is on LinkedIn. You can just find me, Matthew with one T, Picardal, Picardal, Mathew Picardal on LinkedIn. Or you can also find me on my YouTube channel. You can just go on YouTube and type in Matt Picardal, Matt with one T, and my name. There's not that, you should be able to find it. There's not that many.
Awesome. Awesome. Well, thank you so much for coming on. Really, really enjoyed it.
No problem. It was a pleasure, Jared. Thanks.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, episode 21, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the best in all of your geotechnical engineering endeavors. Peace.